A deeper look at the moon Dione. Welcome to another video. If you enjoy this type of content, then subscribe and hit the bell icon so you never miss out on any of our latest and greatest uploads. Giovani Cassini discovered Dione on March 21st, 1684. Dione is a small moon of 349 miles, or 562 kilometers in mean radius, orbiting Saturn every 2.9 days at a distance of 234,500 miles, or 377,400 kilometers, which is roughly the same distance that our moon orbits the Earth. Dione's density is 1.48 times that of liquid water, suggesting that about a third of Dione is made up of a dense core, probably silicate rock, with the remainder of its material being ice. At Dione's average temperature of minus 304 degrees Fahrenheit, or minus 186 degrees Celsius, or 87 kelvins, ice is very hard and behaves like rock. Very fine ice powder, equivalent to smoke, from Saturn's E-ring constantly bombards Dione. The dust in the E-ring ultimately comes from Enceladus, which has prominent geyser activity. Surface. Dione's features include heavily cratered terrain, with craters as large as 62 miles or 100 kilometers across, as well as moderately cratered plains, lightly cratered plains, and fractured areas. The heavily cratered areas are the most common on the trailing hemisphere. Logically, a moon's leading hemisphere should be the more heavily cratered, so it has been theorized that a more recent impact spun Dione around. It has been calculated that bodies as small as those that made 22-mile or 35-kilometer craters on Dione could have spun the moon around to its current position. However, the fact that Dione seems to have spun exactly 180 degrees is a mystery. Fractured areas, seen in Voyager images as bright and thin wispy lines, have lengths of tens to hundreds of miles, often cutting through plains and craters. Cassini flybys starting in 2005 showed the wisps as bright canyon ice walls, some of them several hundred meters high, probably caused by subsidence cracking. The walls are bright because darker material falls off them, exposing bright water ice. These fracture cliffs suggest Dione experienced tectonic activity in its past. They could be a mature phase of the so-called tiger stripes on Enceladus. Just like Earth's moon, Dione is phase-locked with its parent. One side always faces toward Saturn. Likewise, Dione has gravitationally locked two much smaller moons. Heleni orbits Saturn 60 degrees ahead of Dione, and Polyus orbits Saturn 60 degrees behind Dione. These tidally locked moon locations are also referred to as Lagrangian points, L4 for the leading spot and L5 for the trailing spot, based on calculations of the French astronomer Joseph-Louis Lagrange in 1772. Dione is in resonance with two nearby moons, Mimus and Enceladus. That is, these moons speed up slightly as they approach each other and slow down as they draw away, causing their orbits to vary slightly in a long series of complex changes, which helps keep them locked in their positions. Dione keeps Enceladus locked at a period exactly one-half that of its own orbital period. And with that, we've reached the end of this video. If you've enjoyed this video and found it helpful, don't forget to leave a like and subscribe for content just like it.